This video will go over how to set up trains in Hammerhead V2. The biggest difference between setting up a train in V1 and V2 is that in V2, trains use bogies to determine the car's position and orientation along the track, whereas in V1, this was just calculated from the center of the car, which didn't allow for terribly realistic behavior. Unfortunately, setting up a train in V2 is a little bit more complicated as a result, but hopefully this video can help shed some light on how to do it. So the first thing I'm going to start off with is creating the models within my train. So I'm going to select all my bogie models, and a bogie is just a set of wheels. So I have one here, I have one here, and these are just my wheel assemblies here. They need to be modeled, bogies and cars need to be modeled starting from 1, with 1 at the front of the train, and in this case 12 at the very back. So I'm going to group all my bogies into a model called bogies, and I'm going to group all my cars, into a model named cars. So starting with bogey 1, because I already have the rest of them set up, I'm going to select everything under bogey 1 and group it into a model called, well, model. And under that model, if I have any wheels, I need to select them and group them into a model named wheels. Now the rest of my wheels have been set up, but here's how to set up a wheel model from scratch. So I'm going to drag this model into wheels. So this is the one that I want to set up. So your wheels, delete that, need, well, to be named wheel first of all. And you need a model under this wheel model named spin model. This is what Hammerhead will physically rotate, and the wheel will rotate about its x-axis. So you can see that as the little red axis here. So this is pointed in the direction I want the wheel to spin. You need to be looking at the local axes when you check this, and that is indicated by the little blue L right here. Whereas if I press Control L to switch into global mode, you'll see something completely different. So again, press Control L if you are not in local mode, and verify that you are with this little L right here. So now that we're looking at our local axes, verify that red, aka X, is pointed in the direction you want the wheel to spin. Now let's say, for example, it's not. Let's say your wheel looks something like this. Then you would go up here to Pivot under the Model tab, click Pivot, and your little tool should look like this. Then you just rotate it until the red axis is aligned with the direction you want the wheel to spin. Also, when you're playing the game, if you notice your wheel is spinning backwards, just flip the red axis by 180 degrees. So I'm going to grab actually the Z axis to do this. I'm just going to flip it over. And so you'll notice the red axis is still flat in the direction I want the wheel to spin, but it's been flipped 180 degrees, so now the wheel will hopefully rotate in the right direction. Okay. You also need another part under your wheel named reference. This reference part is what Hammerhead uses to, it basically takes the reference part, multiplies it by a certain angle to get your spin model's rotation. So your reference part needs to have the same position and orientation as your spin model. So I'm going to go to my spin model, copy my origin's position, and go to reference part, and paste it under its C-frames position. And I'm going to do the same for the orientation property as well here. And so now my reference part should be oriented and positioned the same as my wheel. Now I'm just going to set its size to something really small. I'm going to make it transparent. I'm going to make it non-collidable. And finally, I'm going to anchor it. This is very important because if you don't do this, it's going to mess everything up when the game loads in. Okay, so now we've set up one of our wheels. So what about the rest of this model here? Your bogie model needs to be, well, first of all, make sure your pivot is centered. So click Reset Pivot, and that'll center it in the model. Then look at its axes. So here, I'm looking once again at its local axes, and I can see that its red axis, so X, is oriented in the direction I want the bogie to pitch. So it's pointed forwards. Or if you go into the move tools, the x-axis should be pointed sideways like this. That's how you can tell that your bogie is oriented correctly. And once again, if it's not, just go up here and edit the pivot. Make sure that you are editing this model, not this model. For your cars and your bogies, you need to be editing the model under them because this is what Hammerhead actually moves. Hammerhead does not move this model. Hammerhead moves this model. So with that out of the way, another thing you want to do is make sure that your origins or your pivots y-axis is the same for all, or your, sorry, y-coordinate is the same for all of your bogies. So by that I mean I already have the rest of my bogies set up. So I'm going to go ahead and check their pivot. And you can see here that their Y position is actually 3.04. So I'm going to go into my bogey here, and I'm going to copy that to be 3.04. Another thing I just noticed is that this bogey is going to probably spawn in backwards. The reason I could tell is because this bogey I know works fine. Its orientation is 0 and positive 90 degrees on the y-axis, whereas this one that I just made is negative 90 degrees. So to fix this, I'm just going to flip it around 180 degrees. So if you notice your bogeys are spawning in backwards, do that. And make sure all of your bogeys have the same position and, or not position, but Y value under position, and that they have the same orientation. Finally, I need to create a settings folder under my bogeys model. This settings folder will have 3 different values within it. It's going to need to have yaw locked, roll locked, and pitch locked, as well as another one called a reference bogey. So the first 3 are going to be bool values. So I'll name this one pitch locked, then I'll have roll locked and yaw locked, and finally I'll have an object value named reference bogey. So what this basically allows you to do is lock one or more of your bogey's axes of rotation to that of another bogey. So this isn't particularly relevant for this train specifically, but if your train has a zero car, then that zero car should only be able to roll independently. Its pitch and yaw axes will be locked to that of the bogey behind it. So if I wanted to do something like that for this train, I might select these 2 values, set their values to true, and set the reference bogey value to the model of the bogey I want it to be locked to. But in this case, I don't want to do that for this train. I want this bogey to rotate independently on all 3 axes. So that's how we set up a bogey. Let's look at our cars now. So starting with car 1, I'm going to go ahead and group everything under this into a model. Make sure I have that all right. Yep. Okay, and now that I've done that, I also want to go up here and I want to create a folder. And this folder will be named bogies. It will have 2 object values. So I'll make the first one. The first one should be named 1. And they need to have 3 attributes within them that they're all booleans. The first one is named pitch. The second one is named yaw. And the third one is named roll. So what these values do is basically they tell the car, okay, so this bogey can influence my rotation on the pitch, roll, and yaw axes. So for a car, especially if you have 2 bogies, you don't need each bogey to influence each axis, but you need at least 1 bogey to influence each axis, or else the car just won't rotate at all in that axis, which is not what you're looking for. So you need object values named 1 and 2, but you only need to set the value of the first bogey. However, in this case, so my first car model is going to use bogey 1 and bogey 2, so I'll go ahead and set the value of bogey 2 as well to the bogey model. And that'll tell the car to use both bogies when calculating its position and orientation along the track. Going back to this model here, we need to have a part within it. Oops. A part. And you can name this part anything, but just for simplicity's sake, I'll name it primary part. And what we're going to do with this part is set it as our car's primary part. So I need to set this to primary part. And probably just to make this easier, I'll grab everything else under the car and group it. So it looks like that. You don't have to do that, but it just makes it a little easier to see what we're doing. So primary part, its position and orientation will become the car's pivot. Kind of like how we did our bogies, except we didn't use primary parts for our bogies, just the car. And once again, I'm going to make sure this part is anchored, transparent, and non-collidable. And I'll set its size to something small. So for my car's primary part, this is done a little weirdly. But the first thing I want to do is make sure, so I'm going to go up to my bogey again, bogey 1. And I'm going to copy its orientation, so 0 and 90, 0. I'm going to go to the primary part and set that as the orientation for the Z-frame. Alright, so now my x-axis is rotated along my pitch axis. Now for cars, so step one, take your bogey's orientation and set that as your primary part's orientation. Then grab this y-axis here and rotate it 90 degrees counterclockwise like so until your z-axis is the one pointed forward. And so for cars, that's the way you have to do that. So now that you've set your primary part's orientation, now you need to set its position. So if you only have one bogey, the primary part's position only needs to equal that bogey's model's world pivot position. But if you have two bogeys influencing a car, then its primary part needs to be averaged, or its primary part's position needs to be averaged to both of their world pivot positions. So the most rudimentary way of doing this is just doing it by hand or manually. Um, and so I guess I can just do that the hard way just to show you how to do that. So let me just go to my favorite little calculator here. And I'm gonna, there we go. Okay. So starting with the x-axis, and I'll just use a positive here. The first value is 474.121, and then I'm going to go to bogey 2, and its x value is 466.976. Divided by 2 equals 470. Equals this number. I'll copy it. But I know it needs to be a negative because both of these were negatives. I just didn't feel like typing it. So go to the primary part, set its position to, under C-frame, set its position to that value, just negative. And you should see now it's kind of in the middle of our train here on this axis. So now for y, I know the y values are the exact same, so we don't need to average them. It's just going to be 3.04. And we'll do it once again for z. So 20.218 plus, it's the exact same. It's 20.218 for both. Okay. Well, we'll just go ahead and set this to 20.218. That makes that easy. And now the primary part should be perfectly in between these two bogeys. So there are the two bogeys. There's the part that should be perfect. Okay, so now let's talk about how to set up restraints. So under this model here, first thing I want you to notice is that I have a bunch of seats. And these seats are invisible parts. You can see me outlining them here within the train. I guess I can make them visible for now. So for each restraint, you you need a model under your train named, well, restraint. And this can be anywhere under this car's model. Like this model can't be above this model, so it can't be parented to car 1. It has to be parented to the model here, but it can be anywhere under this model. It doesn't have to be a direct child. Like, see how it's under another model within the model? That's fine. Just has to be named restraint and located somewhere under that model. So for the restraints, you need to set these up in a specific way as well. So the first thing you want to make is a settings folder, and this is going to be quite beefy here. Your first value is going to be a number value named close duration. This is how many seconds you want it to take for your restraints to close. I think I'll leave mine at 1.5. I'll also duplicate this now and make an open duration value, which is the same thing, but for how long it takes your restraint to open. So I will now make a bool value named closed. And set this to true and don't ever touch this value again. The system uses this value to track whether or not this restraint is open or closed. Your restraints should be closed by default. Now, I guess if you make your restraints open by default, you can set this value to false, but I don't know why you would ever do that. But, sure. So the next value I'm going to set is a number value called degrees empty. So for your restraints, you have degrees empty and degrees occupied. And this basically says, okay, once your restraint is at its full upright position, it will lower either this far if there's nobody in this seat, or it will lower this far if there is somebody in the seat. And if you're just thinking about real life, if there's nobody in a seat, the restraint can press down all the way. But if there is somebody, then their restraint won't, obviously won't go down all the way. You have to go through them to do that. So that's why you can set different values for this one. When determining this value, start with degrees empty and rotate your restraint upwards and track how many degrees that was, then set that as your degrees empty value. For me, I already have a bunch of cars here that are already set up, so I'm just going to go steal these from another car. Okay. So for me, degrees empty is negative 53, and degrees occupied, I would recommend making this, I found experimentally, 8 degrees less. So that would be negative 45. But just play around with it and see what works for you. Now, the reason I'm using negatives is that with my restraint specifically, if I use positives, they start rotating out of the car, whereas negative makes them rotate the right way. So you might need to use negative, you might need to use positive for yours, but just know like if my restraint starts rotating, like if my restraint's up and then it goes like this way, then just change it to a negative. Okay, and then finally we need an object value named seat. And so this is how you connect your restraint to a seat. So I'm just going to select this seat here as my restraint seat. That was, nope, wait, I should select this seat. Whoops. Cool. And now let's talk about how to set up your restraints model. So I'm going to select all these parts here. So this is my restraint model here. And I will name this, well, I'll group it to a model named model. And so this model will rotate about its z-axis. So this blue axis here. So the first thing I note is that my red axis is actually pointing the direction I want it to rotate, because I want it to swing um, in this direction. So the first thing I'm going to do is rotate this so my z-axis is pointed the right direction. So let me just... Okay, so now my z-axis is pointed in the right direction. And again, verify you're looking at the local axes. And then I'm going to move the pivot to the point I want the point I want the restraint to rotate about. So think of it as like the hinge. So to first center this, I'm actually going to select this part. I'm going to get its position, and I'm going to set this as my world pivot position. And then I'm going to move it further down to the point I want it to rotate. Although you can just do it freely by hand if you want to, but that just made it more exact for me. So now the model will rotate like this, which is exactly what I want it to do. And now you're going to need if you want to be able to click your restraint to lower it, add a click detector under this model, like this. Okay, so you'll also need a part named reference part. And this part, similarly to how it was earlier, will be identical to the position and orientation of this model here. So I'll name this reference, set it to transparent, set its size to something small, anchor it, and make it non-collidable. And then I'm going to go to model, select its world pivot position, and set that to the reference C-frame position. And I'll do the same with orientation. So now this reference part is, you see how its position is identical to the models now? Another thing you can do with restraints is you can put two sounds anywhere under this restraint model, although it's easier just to put them under the reference part. And you can name the restraint close and restraint open. And these will play appropriately when the restraint closes or opens. And I already have some that I'm just going to steal really quickly. So like that's the sound it'll play when the restraint closes. Okay. So now that you've done all that, you have your car set up, and then just the easiest way to do this really is to set up your first car and then duplicate it to make the rest of them. So same with your restraint, set up one restraint, then duplicate it to make the rest of them. But now that you have that, let me make these seats invisible again. Your train should be ready to go. So the way to add a train to the coaster is you go to Edit Coasters, then choose your coaster. This video is not sponsored by Chick-fil-A. Add a train. This is messed up because I removed one manually earlier. So it wouldn't look like this on your end. This is because I was messing with it. Then select your train model. It'll tell you if your train is okay or not. And if your train is not okay based off what it's found, it will say the reason why under status. So you just need to fix whatever it's telling you. But if it's acceptable, then you click add train. And then since I've already done my recording for this ride, actually, it looks like my recording is gone, so maybe I won't be doing that. But you would set your action folder and your keyframe folder for the train. Where did the recording go? Whatever. So you'll set your action folder and the keyframe folder for the train like you would in the default tutorial. Towards the end of that tutorial, I went over how to do that. So that is how to set up your train. Another thing to note is that your train must be anchored, so select the entire model. So this is train 2 here. Select the entire model and click anchor up here if it's not already shaded in, and that will make sure everything is anchored under the model. And if you are having any issues, you can play around with the train. Go here. Go to your ride settings, trains, and you can play around with these two orientation offsets. But I would not recommend doing it. I wouldn't recommend changing these values yourself. There's values for playback and recording, but again, this is kind of complicated. But the one that you will probably want to change is up offset. So like if your train is sitting too far under the track, change this value to something higher, like 2. Or if it's sitting too high, change it to like -1 or something. And that will physically move your train up and down along the track. But that covers everything, so that is the end of the train tutorial. Good luck, and if you need any help, the Discord server for this plugin, where I have a bunch of support resources, is linked in the description, as well as the documentation to build the ride.